Welcome to session 15, Pythagorean Theorem, the Hypotenuse. We will build the idea visually, solve a complete example, and finish with a short independent check. By the end, you will be able to verify that a triangle is right before using the Pythagorean Theorem. Locate the hypotenuse as the side opposite the right angle. Estimate and calculate an unknown hypotenuse using squares and a square root. Keep the diagram, the calculation, and the unit connected at every step. Start with the concept visual. The common triples provide fast hypotenuse checks. The coordinate distance is another right triangle application. Read every label as evidence about what is known, what is unknown, and which measurements actually belong in the model. Here is the central reasoning. A 9 minus 50 by 12 minus 50 rectangular room has diagonal. The square root of 9 squared plus 12 squared equals 15 feet. Recognizing the 3 minus 4 minus 5 pattern scaled by 3 provides a fast check. In a right triangle, the hypotenuse is opposite the right angle and is always the longest side. Adding the squares of the legs finds the square of that side, so a square root is required at the end. Label the right angle, the ordered pairs, or the changes before substituting. A diagram that records structure reduces sign and side selection errors. Now add a precision check. Choose an order for the 2 points and keep that order in both coordinate differences. A quick sketch should show horizontal change, vertical change, and any right angle. Simplify exact roots before rounding and check whether a negative, 0, or undefined slope matches the graph's direction. A complete line of work should make the diagram, formula, substitution, arithmetic, unit, and conclusion easy for another learner to audit. Use this repeatable method. First, mark the right angle and label the opposite, longest side, C. Second, substitute the 2 legs into a squared plus b squared equals c squared. Third, add the squares, then take the positive square root because a length cannot be negative. Finally, check that the hypotenuse is longer than either leg but shorter than the sum of the legs. Do not skip the final check simply because the calculator produced a number. Let us model a complete example. A right triangle has legs 8 and 15. What is the hypotenuse? Step 1 is to organize the information. Mark the right angle and label the opposite, longest side, C. Step 2 chooses and sets up the relationship. Substitute the 2 legs into a squared plus b squared equals c squared. Step 3 carries out the mathematics. Use a squared plus b squared equals c squared. 8 squared plus 15 squared equals 289, so c equals 17. A useful check is to take the square root at the end. The answer is 17. Now verify the result against the original wording. The quantity, numerical size, and unit must all make sense together. Now it is your turn. A right triangle has legs 12 and 16. What is the hypotenuse? Write a formula or relationship before calculating, then use the next 6 seconds to finish your reasoning. The model answer is 20. Use a squared plus b squared equals c squared. 12 squared plus 16 squared equals 400, so c equals 20. A useful check is to take the square root at the end. Use this coaching check as well. After calculating c squared, write a separate square root line. Stopping at the squared value is a frequent distractor. Session recap. First, mark the right angle and label the opposite, longest side, C. Next, substitute the 2 legs into a squared plus b squared equals c squared. Then add the squares, then take the positive square root because a length cannot be negative. Finally, check that the hypotenuse is longer than either leg but shorter than the sum of the legs. A strong geometry solution is more than arithmetic. It identifies the requested quantity, represents the structure, calculates carefully, and checks the meaning of the result. Carry that full habit into the next session.